Hello everyone, my name is Jean Denise and I will present you our work Similarity Contrastive Estimation for Self-Supervised Soft Contrastive Learning. Self-supervised learning has drawn attention in the last years to learn a representation of the data without the expensive heavy labelization process. The data, or part of it, is transformed via a pretext task to perform supervision. The different pretext tasks shape how the representation is built, which can improve or worsen fine-tuning. A good representation should be able to contrast unrelated images, align positive views, which are views of the same based image, and maintain relations among the different images. One particularly performant pretext task is called contrastive learning. It consists of creating for each image in a batch two different views called positives. The goal of contrastive learning is to be able to discriminate between positive and negative pairs. However, this objective function lacks the information of semantic similarity between two images. In this example, the query is the middle cat. The contrastive objective brings closer its positive and pushes away every other images. It is relevant to push away the representations of other species, but what about other cats in our dataset? Pushing away such similar images is damageable for a learned representation. Another approach is relational learning, in which relations are modeled and no explicit contrastive learning is performed. This has the advantage to learn better clustered data. Yet, it lacks discriminative information between positive and negative pairs. In our example, this can be shown by the positive view of the cat that is not brought closer to the query than the other cats. We propose a soft contrastive learning approach, Similarity Contrastive Estimation, or SCE for short, that not only contrasts positive pairs to learn discriminative features, but also model relations and pull representations between different images based on these relations. I will now detail its pipeline. First, as for contrastive and relational methods, we adopt a Siamese model with two branches composed of an encoder and a projector. The online branch is updated by gradient descent and the target branch by exponential moving average of the former. Relations between images are estimated by the target branch by computing similarities between each image representation and the memory buffer. These similarities are transformed into a distribution by applying the softmax function sharpened to remove noisy relations. This distribution is mixed with a positive one-hot label and forms the target distribution. The online branch computes similarities between each image representation and their positive as well as the same memory buffer. Then, a softmax less sharp than the target one is applied to form the online distribution. Our training objective is to minimize the cross-entropy between the target and the online distributions. In our experiments, we compared our training objective with standard contrastive and relational learning and showed that our proposed soft contrastive approach outperforms both settings. We also showed that we reach state-of-the-art results, but for less pretending epochs than other approaches, and that our representation can generalize to various downstream tasks. We hope that you can find our approach useful, and to better make use of it and compare our approach with others, we released our code as well as our pretend checkpoints on GitHub. Thank you for your attention.